thank you so much for those lovely words. Also, thank you so much for mapping out how old I am. I stood here about 20 years ago. I was invited to give a keynote presentation at a SETAC. I forget which number it was. How many of you remember that? There. That means I should skip a few of the slides. This picture is a wonderful starting place, because what you see right under my name, that's the only reason why my name is up there, is that there's a little bit of a plastic bag that's bulging up there. That's the new building of the European Chemicals Agency, where we're moving to end of the year. The picture of the old building you won't see here. But this is a typical Finnish day, the picture. And what you're seeing sometimes these days is very untypical for this place. What I was going to talk about is taking the title of your conference and putting it into perspective of chemicals policy, but also looking at what it means in terms of sustainability. And sustainability has been around for a very long time, the word, and in chemicals it entered into the vocabulary of policymakers but also scientists in 1992. Since then it's been relabeled a few times. Today in Europe we call it circular economy. The UN got back to the roots from the 1992 discussions, and now have a new set of goals which are called Sustainable Development Goals. So they're back in the vocabulary, so I assume Europe will follow that soon. What I'll do first is I'll map out a little bit the EU legislative framework for chemicals. Most of you might know it, but I'm doing it for a purpose, and that is to set the scene a bit for why chemicals management, why knowledge on chemicals, why knowledge on the hazards and the effects of the hazards and the exposure of chemicals is so important in order to ensure that this planet has a chance to achieve sustainability. After that, I'll go into looking a bit at where are we in implementing chemicals legislation in Europe, and there I will look a little bit egocentrically and look at the legislation that we implement in the European Chemicals Agency, which is just a small portion of the EU's chemicals legislation. It's REACH, it's classification and labeling, it's biocides, it's PIC, it's POPs, it's a bit on the Waste Framework Directive, it's a bit on the occupational health and safety, then there's a bit on poison centers, and, well, I'll bring that to you in a moment, the little bit that we do. And then looking at that, I want to try to look a bit forward towards sustainability and ask the question, are we on the right path? And where do we need to go to get on the right path if the answer to the question is that we're maybe not on the optimal path? To start with, this is a good slide that sets the scene of, I would say, much of the chemicals legislation in the EU, and in particular that we implement in the Chemicals Agency. The idea is that if you protect human health and the environment, then you're doing it through a regulation like REACH or classification and labeling or the many other regulations we have. Then through setting a minimum standard of environment and health protection, we ensure that the internal market functions well. There's nobody in one part of Europe which can have a competitive advantage towards somebody in another part of Europe just because they haven't done the tests to ensure that their chemical is safe, just because they haven't met the legislative requirements. So protecting human health and the environment in the chemicals area is a huge contributor to the functioning of Europe and its internal market. It also, if we make sure that we do it in a efficient way, generating the information that ensures safety and making it publicly available, we stimulate innovation. Basically, we put economic actors on an equal playing field in terms of information. And that means that if they want to have a competitive advantage over their neighbor, they can't do it based on the information on an individual chemical. They can only do it on the knowledge that they gain from that information in, for example, using the chemical safely, or in the innovative uses of the chemical. But as I'll show, the two hang together very closely: health and environment protection and innovation and the use of a chemical. Finally, it enhances competitiveness. Let me take a little bit of a step back and explain, why does environment and health protection enhance competitiveness? Well, if you look at Europe and you look at the competitive advantages that European industry has over the rest of the world, it's not on the cost of labor. We have high labor costs. It's not on cheap energy. We have high energy prices in Europe. It's not on access to raw materials. We have very little raw material in Europe. And that's, by the way, one of the reasons when we get talking circular economy, why Europe can be the champion. But what is it that makes us competitive in Europe? Well, it's two things in the chemicals area. It's innovation, it's knowledge, it's what the people working in Europe have in their minds. That's one competitive advantage that we have. Another one is still our infrastructure. The Chinese are trying to catch up, but in Europe we still have the best chemical manufacturing infrastructure in the world, and that will still hold for quite some time. But that's not what my talk's about. So it's about knowledge, it's about knowing your chemicals, it's knowing your chemistry, and it's thereby finding new uses of old chemicals or finding new chemicals for existing uses, or even more innovative, finding new chemicals for new uses. That's where our innovative potential lays. And therefore, if we have a lot of information on environment that ensures that those chemicals that we innovate into can be used safely, those chemicals will not be restricted by a Stockholm Convention, as the keynote speaker spoke about yesterday. They will not be restricted through a regulation like REACH. You will not be sued in the US for using the chemical and then having to pay lots of money through the court system there. You simply can show your chemicals are safe, and that's an innovation that we in Europe can build on. So that's how environment health protection actually feeds into all the other main objectives of the Union. And to a large extent, if you go to circularity, circular economy, then what we're looking at there is we're looking at a system where a molecule that should enter into the circular economy, of course, has to exert its function. It has to dye textile red, or it needs to give a hard coating to a part for an aircraft that ensures that the aircraft will be able to land at minus 20, or to give a softening effect to a plastic. But it also needs to be able to do two other things. One is the molecule needs to be recyclable, or at least the material that molecule is part of needs to be recyclable. And in a circular economy, it needs to be recyclable a multiple amount of times. I won't go much more into that model, but whenever I talk about circularity of the material, I also mean that one can extract the molecule back from the material in some way, of course, adding energy. And the third bit is, since we're sending molecules into the economy and we want it to be circular, those molecules are going to stay around for a very, very long time. And if a molecule needs to stay around for a very, very long time, we of course want to be sure that it can be used safely. So those are the three legs on which chemicals in a circular economy stands: its intended use, its recyclability, and that it can be used safely. But let me get back to now. Our legislative framework is very often labeled, it's very complex. I would say it's very complete, but actually rather straightforward. The only question is that you shouldn't be looking at it too closely. You need to step back enough, then you can see the simplicity. We basically have a lot of targeted legislation that looks at products, cosmetic, toys, plant protection products, biocides, pharmaceuticals, veterinary medicines, precursors for bombs. You have lots of other product legislation. Then we have targeted legislation on populations. The most prominent one is worker protection. This is in the the Chemical Agents Directives and its daughter legislation. But we also have, for example, a General Product Safety Directive that protects consumers against chemicals, etc. Then we have various environment legislation on water, on soil, on waste. And in between all of that, you have REACH and CLP, and I start with REACH. REACH is a data generator and gap filler. So the idea with REACH was take that legislation in the previous slide, and wherever there was a gap, REACH fills it. And then on top of that, wherever there was no data, make sure that REACH generates the data. So that's REACH. And then CLP implements the globally harmonized system, thereby ensuring that we do hazard assessment harmonized across all pieces of legislation, and by the way, across the whole world. And to that previous slide, what REACH does, it does 5 things. It poses minimum information requirements so that the people doing cosmetics, so that the people doing food contact materials, so the people doing toys have all the same data coming from REACH when they do their assessments. And by the way, us in REACH too. There's an obligation to apply GHS, which means also that the hazard assessment is harmonized across all pieces of legislation. So you don't end up having different hazard calls left and right for the same chemical across different legislations. There's an obligation to risk assess. Now that obligation exists in many pieces of legislation already, but it's now being done with more detailed methodology. So that's what REACH does. Obligation to risk manage. Again, you have that in many pieces of legislation, but it's done with consistent methodology under REACH. And then the most important part, beyond the minimum information requirements in GHS, is there's an obligation to document. So that's REACH, is those 5 points. REACH interfaces with every single piece of legislation that we have in Europe, simply because it is this gap filler, and thereby also the classification and labeling regulation interacts with all pieces of legislation across Europe. Now, what we try to do, and that connects with the talk yesterday on persistent organic pollutants, and to a certain extent what we in Europe call PBTs, right? Persistent bioaccumulative and toxic substances. So we try to be predictive. So that means that what we're trying to do here in the data generation is to get the data that enables us to predict where the problems are and then tackle them before the chemicals do end up on the North Pole and cause problems there. And if we generate the right data and we feed it properly into the other pieces of legislation, then economic operators will have the information to ensure safety, and thereby they can document that beautifully in the REACH dossier to show that whatever substance they have, whether it's used in cosmetics or it's used in toys or it's used there, it can be used safely. Now, you might have heard that there are certain problems with REACH. You might also have heard that there are quite a lot of successes with REACH. Let me start with the successes. That's always a good starting point. We now finally have a system that's up and running in the sense that over the last 12 years, we've been phasing in substances into REACH. So in effect, there's been an exemption for REACH requirements for a lot of substances from the very beginning up until mid-last year. And mid-last year, finally, all substances above 1 ton are registered. Industry did an enormous task in producing their registration dossiers and doing the best job that they thought they could. And now, 2018, basically June 1st, the system is complete. We have all the data, we have all the industries involved, and now we can start really reaping in the benefits of REACH that I had up on the first slide of all chemicals legislation based on knowledge. Now, there are two parts of REACH which particularly need further attention, so those are the problem areas. It turns out that industry was less compliant than we had originally estimated way back when, and by the way, that was a guesstimate. It was not an estimate, because we didn't have REACH before, so you couldn't estimate, you could just guesstimate. And this basically means that there are many more dossiers that we in ECHA need to look at in order to get the data compliant, and there we're doing a lot of efforts in order to get that done. And our target is by 2027 to have looked at all registered substances, looked at all the data, and basically be able to go out and say, look, the data that we now have is solid. That data that we have in 2027 is what we had hoped to have in 2020 when all of this started in 2002, which was based on a hope from 1992. So actually 7 years late is not all that bad. So that's a bit one of the problems that we got. The other one is authorization. I won't get into the technicalities of that unless somebody has a question, then I'd happily do that. But there are certain issues in authorization. Again, we're very well aware of what it is, and the idea is now we're going to move forward and get those problems solved so that by the end of the year we know exactly what to do, when and how, and we have buy-in from all stakeholders that that's the right thing to do, and then roll up the sleeves and get going in order to get REACH to do what it was intended to do, to generate data and to risk manage, thereby making all the other legislation also work. Okay, with that in mind, how does chemicals management contribute to the circular economy? Well, here's sort of the picture of the circular economy. Again, it's an issue of just taking enough steps back, and then you see the simplicity of it. Circular economy is all about trying to reuse materials. It's not about, of course, it's about repairing glasses. It's about washing a drinking glass off. But at some point, the material itself needs to be recreated in order to create a new article. And the objective of circularity is that we can do that an infinite number of times. Now, most people in circular economy, you not, the audience here exempt, think of materials as being the endpoint of circularity. But actually, a material is always a mixture of chemicals. Once in a while, it's also a chemical, but it's never anything else. It's either a mixture or a chemical. And this basically means that when you talk circular economy, what it's all about is to take mixtures and make sure that a mixture can stay in a nice cycle. Which means that our waste colleagues need to rethink their world a little bit, because they normally stop once they see something that looks homogeneous coming in as a waste flow and then comes out as a material afterwards. No, they have to see this as maybe a composite of a lot of mixtures. But luckily, we in the chemicals area know how to deal with that. Whenever a company imports a mixture from somewhere, then they have to register the substances individually. So that means that they already know how to either divide up a mixture into different substances, or they know how to ask back there what is actually in it. So we have a lot of experience on that. And this basically also means that the whole fundament of the circular economy is chemicals. And that also makes a lot of sense, because if you look at our linear economy, well, our linear economy is one where first you start with something and eventually get an article. Well, you start with extracting, right? You extract something, raw oil, you extract biomass, or you extract metals. And then from there on, you manufacture a chemical that then goes through, becomes a mixture, goes into an article, and then it gets sold, thrown away. There are only three endpoints of an article. You can either landfill it, you can burn it, or you can house fill it. House fill, that's my terminology for recycling, because what you do is you take the article and you put it into your house or the office building or the road or something like that. So it's a shortcut for recycling. And since in Europe we want to ban landfilling, and since in Europe we're not very heavily supporting incineration, then house filling is the agenda of the day. It's called recovery, or it's called recycling, but that's where we want to go. And therefore, looking at the world from a chemicals angle is the ultimate model to combine what's happening in the waste phase and what's happening in the chemicals phase. So therefore, there is, from a technical perspective, a need for some sort of merging of the world that the waste people live in and the world that we chemicals people live in. Well, what has gone well, what has gone less well, what's not gone so well, what's gone bad, and what needs to go better. This we need to do because if the end point is that basically the world has to be looked at from a chemicals angle, if we have rather complete chemicals legislation, then what it's all about is to make that chemicals legislation fulfill its objectives, but also to make sure that we have the right chemicals that goes into the circular economy. And for that, we have to know what's going right, what wrong, and needs to be done better. Here's another representation of what I was talking about before, about REACH, CLP, and all the other pieces of legislation. And there we have lots of successes, but we also have lots of not so successes. If we start with some of the successes, then after many, many, many years, we now finally have a convergence of the setting of a DNL in REACH, derived no effect level, and an occupational exposure limit value in OSH. So here on the very, very top, you see that the Risk Assessment Committee of ECHA will be evaluating both of them with similar methodologies. So the science-based proposal for an occupational exposure limit value and a science-based derived no effect level will basically be the same. But that took a lot of energy and a lot of time, but there's a convergence starting. Food contact materials, another good convergence. Based on the human biomonitoring data that's developed under the RTD project. Well, actually, it was developed under Life Plus and RTD money before that. We in ECHA did a restrictions proposal where we looked at all exposure from consumers to phthalates. And if you use human biomonitoring data, you of course have to factor out the exposure that comes from uses that are not covered by your turf. And food contact materials not covered by our turf. So we had to calculate that 2/3 of the exposure to humans in Europe comes from food contact material and 1/3 comes from everything else. And the 1/3 is a risk. I can see that most of you would know what that means for the 2/3. EFSA is currently assessing that. Exact same data, exact same exposures. And hopefully they'll come to a consistent conclusion as we did, and we're of course working with them to do so. Waste, well, there are a number of the issues, the problems. If you've read the Commission's communication on chemical product waste interface, then you'll see that there are a number of issues. Basically, there's not an equal playing field between being hazardous in waste and being hazardous in REACH. And this basically means that you think you're not hazardous in waste, but then as soon as you say, okay, now I'm going to recycle that material that's not hazardous in waste, it becomes hazardous in REACH, and that creates friction. And very often it's said, well, then it's REACH's fault because it makes something hazardous that wasn't hazardous before. But that's a little bit beside the point, because if it's hazardous whether you know it or not. It's sort of like saying, oops, nickel just became nickel has been a carcinogen. I need to take another substance, but say substance X all of a sudden became reprotox because RAC said it's reprotox. No, it was reprotox for a very long time before that. It's just we happen now to know it. So it's not an issue of trying to work against the fact that it all of a sudden became reprotox. It's an issue of trying to roll up the sleeves and now live in the world where substance X is reprotox. But that's a type of interface where we definitely have problems today. Another place where, for example, it has worked or it has not worked. If I go to the persistent organic pollutants, that's a good topic that was covered yesterday. I also think the keynote presentation tomorrow will be talking about persistent organic pollutants, and it's definitely work that's very close to my heart that unfortunately in ECHA I'm not allowed to do anymore. But there's when we've restricted a POPs in Europe and we go to the Stockholm Convention, then basically our dossier is robust enough to stand up the scrutiny in the Stockholm Convention. However, what does happen, and that was what happened now, 2 years ago, was that a substance which one big American airline company could substitute, they managed to do it, not airline, so passenger aircraft producer, sorry, a very big one. I'm just saying this so that we can keep the names confidential. They were able to substitute the substance, where a huge European commercial airline aircraft producer was not able to. But they forgot to tell us about that when we did the EU work, but then they thought about it when we did the UN work. And this meant basically that we had to go to the UN saying, oops, we need an exemption where the rest of the world doesn't. So also there, when you go to, for example, POPs, there are quite a lot of difficulties in ensuring that the information basis on which we take a decision is consistent all along. And most inconsistencies happen only because the information basis is not the same. It's not because the scientists have totally different ideas. It's simply because the data that they're looking at is different. So, of course, they get different conclusions. And I think this one example with the two commercial aircraft producers is a good one to illustrate. We need a common information basis, much more accessible, to ensure that decisions can be made consistently in Europe, but also across the world. So those are a few examples. I can also mention another example of these interfaces, which we're going through right now, microplastics. ECHA has just done a restrictions proposal. So the Secretariat of the agency has done a restrictions proposal for intentionally added microplastics in any good, and that's now being discussed in our scientific committees. And basically what we're looking at there is, for example, an interface with fertilizers. And there we know that there's legislation in Europe, but some fertilizers is plastic encapsulated in order to enable it to be released longer, and there the plastic remains behind, and we've done an assessment of that. So that's one of these interfaces here with another piece of legislation that I don't have up there. Okay, so I have here something on the screen. It's telling me, Bjorn, please stop. I think I can better just do OK. Whatever it said, and then I'll press the green button, and it worked. Very good. Talking about improvising. So when we take the learnings from where things go well and where things don't go well, and we move it into a circular economy setting, and basically in the world of circular economy, like I told you before, there are only two places you can be. You're either REACH or you're waste. There's everything in this room except a few things which are purposely exempted from REACH. You're always in one of those two. And given the fact that you're either in one of those two, clearly this interface needs to be improved. And that was what I was talking about the need that we start speaking the same language in the two worlds, but also see the world in the same way. We have the same model. We have the same idea that, yes, it's all about mixtures moving around in a circle. Second of all, the REACH phase, which I've purposefully left out all the boxes about toys and cosmetics and da-di-da-di-da, but that interface, of course, has to work also. Improved. We have to, and how to improve that? It's definitely, we need equal access to all available information that is there on a chemical, which is not only regulatory information, it's also research information. And this is where my my question about the 20 years ago when I stood here, and I definitely looked a lot younger, was because there I made a plea, and I'm going to make that plea the same now. If every research project in this world that has something to do with a chemical would get 1% more funding, and that 1% more funding goes into filling in a Euclid data sheet, identifying the substance with a CUS number, not just a name or an abbreviation where we have to guess the purity and all sorts of other things, and fill in all the data in a format, in a way that enables people quickly to access it. And here I don't just mean ECHA, I also mean industry. Then they can much easier do literature searches. And it's 1%. It's maybe 1% of the total volume that is needed. And all of a sudden, all the research that's being done becomes much more accessible, rather than us having to sit there and say, okay, they tested a PCB. Okay. Which one? Purity. Da-di-da-di-da. And that was not the interest of the scientist, but it's always the interest of us when we use the data. So that's issue number one. This year is really going to be helped if we manage to get all data available in an accessible format, and such simplistic things like CAS number, purity, test duration, species, strain, all these very boring stuff are elementary for that, and very often you don't find them in a scientific publication because that was not the target of the scientific publication. Then, whoops, what other ideas? We also need, clearly, if we manage to get all that data gathered in not in a specific format, but accessible through the same parameters, then we need all of that to be accessible for everybody, so that everybody can use this wealth of information. And why do we want that? Well, it's a little bit this thing about, has two components. If we give a lot of information out in a format that people can access like you, first of all, you'll be able to get funding to data mine a lot easier than if you didn't have that information. Second of all, your results you can just put back into the database once you've done your data mining. The second thing is, the more you guys do data mining, the more we in Europe, and sorry, here I'm speaking in particular to the Europeans sitting around here, the better we are going to get at data mining, the better we're going to get at understanding what's going on with chemicals from a safety and health angle. And the more we know that, the bit more we're building a European competence, which, back to my first slide, is one of our few competitive advantages towards the rest of the world. So I think that maps out more or less the main issues that I think an audience like yours, like we have here, like you, would need to reflect on to see how you, with your work, can contribute towards a circular economy, but maybe also how you, with your work, can actually contribute to creating the knowledge that we need in this world to ensure the safe use of chemicals. So thank you so much, and there's still a bit of time, hopefully, for a question or two that you might have. Thank you.
Thank you, Bjorn. And time for questions. Okay.
Thank you. Mamta Patel from Chemical Watch. Bjorn, the issues of sustainability are multifaceted, and there are many different values that come to play in making decisions, particularly for regulators and policymakers. I wondered if you could comment on that, because it follows a very interesting debate that SETAC has hosted earlier today.
Yes, I think there I won't go into grand detail. I think there are different facets. One is robustness. How do we create a system where an individual person's potential bias and scientist, not purposeful, is averaged out? Well, our European system of 28, soon to be 27, member state experts discussing openly and transparently, basically until they reach consensus, is one fabulous mechanism to ensure that unintentional bias, which can come from different values of scientists, gets averaged out. The law of large numbers just plays there. The more member states we are, the better the result will be. I also think that there's also a difference between the values that a scientist, I think a scientist needs to have a lot of values. One of them, for example, is that they have a duty to explain what they know to the people who have a need to know. For example, on chemicals, people like us in ECHA, but in particular also in Brussels. But there's a very fine difference between what are the things that scientists, or say regulatory scientists, can look at compared to what a policymaker can look at. And I'll give a very good example from recent discussions on authorization. So I do get into a technicality here. We had an application for chromium use to dye wool very black with a little bit of a red shine on it, which was used in high-end suits, really chic and very pretty. And the question is then asked now, that's what we need to reflect on, is would a normal black without that red shine, or one that doesn't hold up, say in the dry cleaners 20 times, be fine? Well, scientifically you can't make that judgment. That's only a judgment that the policymaker can make based on weighing a number of various other factors. So I think there are two, I mean, off the top of my head, two effective issues. The one is the natural unknown bias that comes in from everybody. I mean, we're all biased from our education where we've lived. I mean, I try to speak British, though I learned English in America, and you can hear the result. So we're all biased in a certain way, and therefore the machinery has to be one that tries to minimize that bias, at least that bias can have an influence on the outcome of the result. The other one is also to be clear in one's mind in terms of what is the area on which we can do and make opinions on science and technical things compared to what is really policy making. And the danger there is that very often both realms use the same word for different things. So I guess communication and clarity and discussion is important. So could you have a session on that?
Well, what I really like and what I really appreciate was your strong plea for open accessibility of data. And you focused very much on the scientists, and I focus back a little bit now. So of course, scientific data should be available, should be accessible, and well, for everybody. But let's see it the other way around too. So what about all these, let's say, data on what is produced, where and in which tonnages, and it's used in which products, and so on. So as a scientist, we are looking very often for things which other people in industry, for example, already know. And we spend a lot of money and a lot of efforts for doing that. So this open accessibility of data on things like that would be also a great thing.
One comment, and then I'll get to the other part of the equation. I heard a Director General from DG Environment speaking about what is the future of European industry. I mean, I mapped out from a chemicals angle. He was mapping out two very important factors that will drive industry, and one of them is IT, is data, is what I forget what is cloud and all of this stuff. And therefore, actually, in terms of knowledge and getting it all out there in order to data mine, it's not only a dream, it's also linked up with, there are people in high-ranking places who think that this access to information is not only good for transparency and research and everything else, it's good for industry as a whole. Now, on your question about which information we have accessible, well, the bureaucratic answer is, of course, we have these rules and da-di-da-di-da, and we have to fulfill the rules, and that's why we can't let the tonnages and the exact uses and the emissions. But I fully subscribe to the fact that the more of this information is available, the better science, the better science-based decisions ultimately will be made. So any company who by themselves gives information free is a contribution to the building of a competence and a knowledge which ultimately will serve their chemicals, because the more we know, the better decisions we can take. And I think if you look at Europe, and you look at what's happened in the food law and the grilling that my colleague in the European Food Safety Agency has gone through over the last 2 years and sustained fantastically in that grilling, is the outcome was basically a new transparency law for food, where a lot more information is being made available than was before. And I'm sure that that is not a tendency that's going to stop there. I think that that is a general tendency that, like so many, will snowball, because there's so many arguments that speak towards transparency, and actually there are ever less arguments speaking towards the other way around. So I would say yes, perfectly agree, the more the better. And the better for everybody, including the individual companies putting the substances on the market. But it takes some time to get there. There's some hurdles we have to get over.
Okay, I saw 2 hands being raised, one there and one there. So we take these 2 questions and then we close.
Okay, thank you.
Thank you.
Thank you. Cheryl Woodard, RVM. Bjorn, you mentioned hurdles. One of the hurdles you mentioned was the difference in labeling a chemical in REACH versus that in waste. You mentioned the example, a chemical can be just as non-hazardous in waste legislation, whereas once it gets into the REACH, then it's hazardous. And to be honest, that doesn't seem to be a major hurdle to overcome. Is that difficult to streamline that? And could you explain why it is?
The reason, yes, I can explain why. I mean, one example, for example, is that the M factors that are used in environment classification in the REACH CLP world are not used in the waste world, just as one angle. Yeah, and I mean the reasoning behind it is objectively completely logical. It is that hazardous waste is really difficult to transport. The rules for transporting hazardous waste from one site to another are much more difficult than non-hazardous waste. And basically, if we have a policy, which we have in Europe, about improving recycling, then having to transport hazardous waste increases costs and thereby reduces recycling, if that material fulfills the hazard criteria, which a lot do. So it's totally logical that in order to promote recycling, one alleviates the economic burden of putting the rules for hazardous waste onto that material. But what I'm saying is, at some point, those various policy objectives, where crudely speaking in the waste area, there's a huge push towards recycling. In the chemicals area, there's a huge push towards, we don't care if you recycle or not, but don't put SVHCs in there, just as an example. And sometimes those 2 policy objectives clash, and it's in that clash that creates the friction and thereby reduces the ability to recycle good chemicals ultimately. So that's an example. The objectives are different, which is perfectly fair. You know, that's what politicians and policymakers should do. But if we want circularity, at some point they have to come together.
Marco Vighi from India Water in Spain. I have a very specific question, but that probably can help us to understand some procedure for ECHA decision. You mentioned the recent proposal for the control of intentionally used microplastic. However, there is enough experimental evidence that primary microplastic represent a very minor percentage of the plastic that we can find in the environment, at least from the monitoring data that are available. So probably no more, probably less than 1% of the total. So my question is, how do you evaluate the effectiveness of such a proposal? Is based on scientific evidence, or there are other evaluation behind?
It's scientific, of course, but the way we look and define risk assessment under REACH is not the classical, you have to have a toxic effect where you kill a fish. There's an enormous amount of flexibility in regulatory risk assessment already introduced 20 years ago and moved over to REACH. Now, our conclusion is that that 1% actually matters. And that's something that matters that we can do something about within our realm, because we're a chemicals agency, not a waste agency. The 99% is waste. The 99% of the waste, or the generated microplastics that we see in the marine environment comes from macroplastics that was from poorly disposed waste. Now, the difference is that when we look at our assessment, it's in particular European soils that's where plastic ends up. And that's not the pathway for the 1%. That's not the pathway that the other 99% ends up going. That pathway is mainly aquatic, mainly microplastics into the marine that then gets crumbled up into microplastics. So go in and read the proposal. There is a justification on there, but fully aware that we're addressing 1% of the problem. But it's a little bit like the phthalates. If 1/3 of the phthalate exposure gives you a problem, you also know that you can extrapolate to the rest relatively quickly. And it's the same here with microplastics, intentionally added microplastic. If 1% is the problem, you can extrapolate to what happens if you have a similar source from somewhere else generating the same types of materials.
Thank you, Bjorn. Thanks a lot. And I think it was a very fantastic keynote speech. So let's thank Bjorn. Thank you very much.